Hello everyone, we're going to be doing section 3.1 today. So this is going to be on linear equations and the rectangular coordinates. So we have 6 objectives. First objective, we want to interpret line graphs. Second, we want to write a solution as an ordered pair. Third, we want to decide whether a given ordered pair is a solution of a given equation. 4, complete ordered pairs for a given equation. 5, complete a table of values. And 6, plot ordered pairs. So let's get started with objective 1 here. We want to interpret line graphs. So a line graph is used to show changes or trends in data over time. To form a line graph, we connect a series of points representing data with line segments. So what we're doing is we are plotting points and then just connecting our lines in between these points. So here we have this line graph of the average US gasoline prices. And so what we see here is that this line graph is representing years to average prices for a gallon of gasoline. So we have our price in dollars per gallon of gasoline on our vertical axis here. And we have our year on our horizontal axis. So this data that we see, it can always be put into a data table instead, as we've seen in the past, but we can see the trends better in a picture or a picture form, such as a line graph. So when we have a line graph, we really see these kinds of trends that are occurring in our situation, that whatever we have. So for example, in our average US gasoline prices, we see our average price of gasoline drops right in the beginning. We see it steadily climb back up and then drop a significant amount more. So we can extend this idea to linear equations with 2 variables. So we've only been dealing with linear equations that have 1 variable, but now we're trying to work out these linear equations that have 2 variables instead. And the graph of a linear equation in 2 variables is going to be a line. So most often we'll see equations set up as with variables of x and y, and when we do, these equations will represent a line. So with our definition here of a linear equation in 2 variables, x and y, can be written in the form of ax plus by is equal to c, where a, b, and c are real numbers and a and b are both not 0. So c can be 0, but a and b would not be 0. This form is called the standard form. So our standard form examples would be something like 3x plus 4y is equal to 9, x minus y is equal to 0, or x plus 2y is equal to negative 8. So you see, we have our 2 variables, x and y. Linear equations in 2 variables that are not written in standard form, such as y is equal to 4x plus 5, and 3x is equal to 7 minus 2y, can be algebraically rewritten in this form, and we'll discuss it a little bit more later. So we can always rewrite any of our problems to be in standard form. So moving on, objective 2. We want to write a solution as an ordered pair. Recall that a solution of an equation is a number that makes the equation true when it replaces the variable. So these would be something like x minus 3 is equal to 5, has a solution x equals 8. So when we plug in 8 into this equation, we get 8 minus 3, which is equal to 5, which is equal to 5. So we have 5 is equal to 5, which is a true statement, meaning that x equals 8 is our solution. But we see here that a solution of a linear equation in 2 variables requires 2 numbers, 1 for each variable. So for example here, if we have y is equal to 4x plus 5, it would have the solutions of x equals 2 and y equals 13. This is because if we choose x equals 2, we plug in x equals 2, and we're solving for y in this case, which would give us 13. Since when we plug in 2, we get 4 times 2, which is 8 plus 5 is 13. So then we write our solution as open parenthesis 2, comma 13, close parenthesis. And this is how we represent our ordered pair. And what we see is that our x value is always going to be first in our ordered pairs. So our ordered pairs in general are written as our x value, comma, y value. So such a pair of numbers is called an ordered pair, where the solutions are a pair of numbers in parentheses and the x value is always given first. So just to reiterate that statement there, x value is always going to be first. Objective 3. We want to decide whether a given ordered pair is a solution of a given equation. For example 1, we just want to decide whether the ordered pair is a solution of the equation. So our equation in this case, and we can detail this here. So our equation is 3x plus 4y is equal to 12, and 1, 2 is our ordered pair. So we write out our solution when beginning and solving the problem. We want to identify that from our ordered pair, our solutions are x equals 1 and y equals 2. So because y is the first number stated in our, because 1 is the first number stated in our ordered pair, x is equal to 1 and 2 is our second number, so y is equal to 2. So we have that x is equal to 1 and y is equal to 2, and now we just want to check and make sure that this is correct and that this is a solution. We're deciding whether it is a solution or not. So now we can make little notes here. Now you can plug in x equals 1 and y equals 2 to decide if they are, in fact, solutions to our equation. So we'll plug in our values. Our original equation was 3x plus 4y is equal to 12. And plugging in our values, this will give us 3 times 1 plus 4 times 2. And we're saying that this is equal to 12. Well, 3 times 1 is just 3. 4 times 2 is just 8. We're saying that this is equal to 12. But 3 plus 8 is equal to 11, not 12. So these numbers are not equal. So we say since our statement or our final statement here is not true, since 11 does not equal 12. So we say since our statement is not true, our ordered pair of 1, 2 is, and let's put this in red, not a solution. So when solving problems like these, we want to plug in our ordered pair, and if we see that our numbers are equal, if we end up with maybe say an 11 equals 11 or a 12 equals 12, then they would be correct and they would be solutions. But since we have 11 does not equal 12, our final answer would be that this ordered pair is not a solution. So all right, objective 4. We want to complete ordered pairs for a given equation. We can substitute a number for one variable to find the value of the other. Example 2, we want to complete the ordered pair for the equation. So this is what we're doing instead. Now we are plugging in the value that we know and we're solving for the other value. So we can identify that in this case, y is equal to 17, but we need to solve for x. So we plug in 17 for y and see if we can solve for x. So our original equation is y is equal to 5x plus 2. Plugging in y is equal to 17. Now we have 17 is equal to 5x plus 2, and we want to solve for x. So we can start by subtracting 2 from both sides. So we got 17 minus 2 is equal to 5x plus 2 minus 2, getting rid of that 2 there. So now we have 15 is equal to 5x. And we want to isolate x as much as possible, so we want to divide each side by 5. And 15 divided by 5 is 3. So we get that x is equal to 3. And since we found that x is equal to 3, this means our solution Sorry, I'm having some things pop up. There we go. Our solution is our ordered pair, which we now know the x value of, which was 3, and our original y value, which was 17. So in this case, we were given one of our values in our ordered pairs, and we just had to solve for the other. Objective 5, we want to complete a table of values. So ordered pairs are often displayed in a table of values. And to put this into practice here, example 3, we want to complete the table of values and write the results as ordered pairs. So our table of values is really just another way that we're representing our ordered pairs, just another way to display them. So what we have here is we have our table. We see on our left-hand column, we have x values, and on our right-hand column, we have y values. So we see that when we have a value in our x column and a value in our y column, we just write those as an ordered pair. So for example, looking at our table, our first row has the x value of 2 and the y value of -2. This means that its ordered pair is going to be 2 and -2. So what we want to do is we just want to complete our table of values. So what we're going to do here is we're going to separate our rows here into 1 and 2 because we'll have to solve them separately. And our equation that we're given is x minus 2y is equal to 6. And because of our table, we are given certain values. So for number 1 here, we're plugging in x equals 4. So x equals 4, and we're going to plug this into our equation. And I'm going to write EQ for equation, EQ. So if we're plugging x equals 4 into our equation, this means that instead of x minus 2y equals 6, we're now going to have 4 minus 2y is equal to 6. And we're solving for y because that's a missing value in our table and also in our ordered pair. So we want to get rid of the 4 on both sides so we can isolate our y terms. So we're going to have 4 minus 2y minus 4 is equal to 6 minus 4. So our 4's will cancel out on our left-hand side and leave us with negative 2y is equal to 6 minus 4, which is positive 2. And now we want y on its own, or 1y, so we need to divide by negative 2. And when we do that, 2 divided by negative 2, which is going to be negative 1. So our y value in our table, when x is equal to 4, is going to be y is equal to negative 1. So we have negative 1, and let's highlight. This was our answer, negative 1. So our ordered pair will be 4, comma, negative 1. And now for our second technically our third row in our table. But our second thing that we're solving for. So we're gonna put this right here, number 2. We don't know our x value, but we do know our y value. So we're gonna say y is equal to 0. And we're going to plug this into our equation. So plugging this into our equation, we're gonna get x minus 2 times 0 is equal to 6. Well, 2 times 0 is just 0, so we have x minus 0 is equal to 6, where x minus 0 is just x. So we get that x is equal to 6, and we can fill this into our table here. So now we have 6, which means that our ordered pair is going to be 6, 0. So in filling in our table, we just want to pick a certain value, whether that be x or y, or if we're given those values and we just want to solve for the other value by plugging that value into our equation, solving for the unknown, and writing out into our ordered pairs. So these tables are just a different way to display the same thing that we're doing when we solve for ordered pairs. Then our last objective, we want to plot ordered pairs. So now we have our ordered pairs and we want to plot them. So every linear equation in 2 variables has an infinite number of ordered pairs, x, y, as solutions. So when we find our solution, like in our previous examples, that would just be one of infinitely many solutions. So there are many solutions to 2 variable linear equations. To graph these solutions, we need 2 number lines, the horizontal line being the x-axis and the vertical line being the y-axis. The point where the 2 axes intersect is called the origin, and this forms the rectangular coordinate system. So our rectangular coordinate system is this image here, where we see we have lines intersecting each other. Our vertical line, or our line that goes up and down, is our y-axis. So these will plot our y values. And our horizontal line is our x-axis, or where we'll plot our x values. And where they intersect there is going to be the origin. And those are where our numbers start. So they start at 0 at the origin. The rectangular coordinate system can be divided into 4 quadrants, which are numbered counterclockwise starting with the top right quadrant. So we see our top right quadrant here is quadrant 1. Then we have quadrant 2 moving counterclockwise. So we move then to the left. Moving down, we have quadrant 3, so still in our counterclockwise position. And then lastly, we finish up with quadrant 4 in the bottom right there. So we have our separate quadrants. The x-axis and the y-axis determine a plane, a flat surface illustrated by a piece of paper. So we say that these are pieces of paper. Our rectangular coordinate system in this case is a plane. We have our y-axis and our x-axis intersecting on top of it. So any point on the axes themselves are not considered a quadrant. So if we identified a point, maybe right here at this mark, which in this case would be a -1, 0 in our ordered pair, because our x value in this case is -1 and our y value is 0. In this case, if we had a point such as this, it would not be considered in a quadrant. If it is on one of the axes, it is not in any quadrant. So by referring to the 2 axes, every point in the plane can be associated with an ordered pair. These numbers are the coordinates of the point. So this -1, 0 that we have plotted, this is an ordered pair, which is also a coordinate. So we're saying that the ordered pair is the coordinate there. In a plane, Both numbers in the ordered pair are needed to locate a point. The ordered pair is the name for the point. So our point is literally going to be that dot. The ordered pair is the name. But that is how we would start to kind of begin by plotting points on a graph. You can choose whether to identify your y value or your x value first, but moving from left to right here on our left-hand side of our x-axis. So our left-hand side, these values are negative. On our right-hand side, these values are positive. Then with our y-axis, we have that above the intersection or above the origin are our positive values. And below our origin is going to be our negative values. And we'll just pick red again, so negative. So we can plot our points on a plane by choosing our x value or our y value, and then finding that corresponding point with the other value that we were given. So as an example, example 4, we want to plot the point in a rectangular coordinate system. So we're given our point here, -2, 1, and we have our rectangular coordinate system here. We have our quadrants, which are labeled, and we have our x-axis and our y-axis, and our paper or our note-taking system is already gridded, so we can kind of follow along here with the values. So, since our point is -2, 1, this means that our x value is -2 and our y value is +1. So what we're going to do here is let's go ahead, find our x value first and then our y value. So our x value is -2. Our x-axis is our horizontal line, I forgot to write that 0, is our horizontal line. So we just need to find -2 on our horizontal line. You can identify our x-axis as just a normal number line. So in this case, we want to identify -2, which is right here. Then our y value we say is +1, which is that value there. Our y-axis or our vertical line here is positive above the origin and negative below the origin. And since we have a +1, we identify that's where our point is. So now, what we can do here is we begin at one of our points. So for example, we can begin at -2, or we can begin at our x value of -2. And what we want to do is we want to track upwards until we reach our y value, which in this case is 1. So we can also track sideways here. And so we can draw our little arrows and identify that this is our point. So whether you choose your y value or your x value first, you want to find those that one point, which in this case is -2, 1. Or if you drew lines out, you want to find where those lines would end up intersecting. Let's just do one more. So let's say now instead, let's do 3 and -1. So in this case, our x value, my cat just decided to lay on my arm. Oh, you're very cute. So our x value in this case is going to be +3. And our y value is going to be -1. So we can do the same thing. Let's start with our y value. Our y value is -1. We'll use a different color. Our y value is -1, and our x value is +3. Beginning with our y value, we just want to track out until we reach our correct x value, which is +3. So we draw our line, and we reach +3. Once we were at our x value, we track down to our point here, which leads us to our coordinate of 3, -1. So that is how we would go ahead and plot points on a rectangular coordinate system. So, all right, that finishes up our section 3.1. So I will see you again for section 3.2.